Good morning, guys. This is your colony challenge rubric, so the pharmaceutical challenge rubric. The first part is a group grade. It is 60 out of 80 points that are total for it. So for the very first part of your presentation, whether you do a PowerPoint, Google slide, a Prezi, a poster, whatever you do for your presentation, a video, you need to make sure that you have the problem stated. And if you want all full credit for it, the advanced over here, you need to make sure that you go above and beyond to demonstrate the understanding of the problem and its real life applications, right? So if you just copy and paste the introductory for your problem statement, that's not going to earn you full credit. That's going to earn you somewhere in this range right here. So make sure you re-explain it in your own words. Do not plagiarize what the problem is. What are we trying to give the patient to save this patient that's in critical condition? Why do we need to do this? What's the difficulty? What's the problem of putting two different IVs together if it makes it precipitate, etc. All right, the next part is the planning and the procedure. And again, in order to earn full credit here, we need to make sure that you use pictures and very few words. Any good presentation, you're explaining what's on the slide. You're not reading the slide itself. So make sure you're taking pictures. Demonstrate a strong understanding of why each step was completed. So explain your lab procedure. Why did you do what you did? Why did you deviate from maybe what was written on the lab procedure? Why did you use an Erlenmeyer flask instead of a beaker? Why did you use a certain type of funnel? All right, so make sure you explain each of those parts in pictures if you want full credit. If you just do it in words and describe how the procedure was used and basically explain, just copy paste again from the actual lab report, then you'll get proficient, maybe unsatisfactory, right? Make sure there's not too much text on the slide. All right, the next part down we have is data and presentation. Data presentation and discussion of the data. So this is where you need to insert pictures of what you did, all your calculations, all of your data that you've collected, how much you weighed of each thing, how much you yielded of each thing, what was your percent error, what was your percent yield. Go back to your notes and look at that, right? So advanced demonstrates exceptional performance. In addition to meeting the proficient criteria, so you need to make sure that you provide data tables related to the yield of the solid. The data table has units and labels. It provides the theoretical yield, that's what you calculated. It also discusses the percent yield. Describe any sources of error. Describe if the sources of error may have affected the data at all. So for example, blank, the percent error was decreased. Something happened, maybe you measured it incorrectly, you added too much, whatever happened, some error happened and it decreased the percent yield because blank, right, would be an if and how statement. So areas for improvement if the lab were done again. If you want to get more than full for proficient, if you want to go advanced, get full credit for that, you need to complete more than one trial. If you had time. If you didn't have time, then say la vie. All sig figs need to be within the desired 2.00 grams of nutrient needed. The lab error discussion demonstrates an exceptional understanding of how the error affected the data. For instance, the percent yield is higher or lower than it should have been because of blank happening in the lab. Provides a data table related to data to determine percent yield of aqueous nutrient. The data table has labels and units, again, and it has a title, and it provides the theoretical yield as a reference. So what were your calculations? Put that into a nice, concise, clear data table with labels and units. All right, the next section that you will be graded on is the nanoscopic representations. And we've been drawing particulate pictures and Lewis structures since the beginning of the school year. So in addition to meeting the proficient criteria, if you want to get advanced, we'll go over that. So proficient, minimal criteria that you need on there. You need the law of conservation of matter, right? Why do we balance equations? Are the proportions logical? Do the numbers stay consistent? Did you magically gain or lose mass, and why if that happened? How the molecules and formula units are represented. So why do we cross our charges? Why do we balance again? Are any states of matter, so solid, liquid, gas, aqueous, are they represented and appropriate where needed? If it is aqueous, are they dissociated? Are they solid, right? Are they splitting apart if it's aqueous? What's the net ionic equation? Are they staying together if it's a solid? How are the water molecules appropriately oriented around the ions? So remember, water has an oxygen, which is partial negative, hydrogen, which is partial positive. Cations like to attract those negative oxygens, and anions like to attract those positive hydrogens on the water. If you need an example, go look at the poster exemplar in the classroom. And then, do polyatomic ions stay intact? Do they stay as one charge, or do they all of a sudden separate into 1,000 different atoms? And then states of matter, do the solids look like solids are supposed to be spaced apart? Do gases look like gases? Do liquids look like liquids, right? So how should they be spaced apart? Solids should be closer, liquids should be a little bit further, gases should be much, much further. And then in addition, if you want the advanced points for that, we have nanoscopic representation of the filtration process that's provided. Exemplar demonstration of understanding of the process of hand. So last year we had posters being made, we had animations in their PowerPoint being made. There was a plethora of things happening last year. So if you want that advanced credit, you want the full credit for this, you need to show that you understand what does it look like when we're dissolving something. So go back to your 12.1 notes, go back to your 12.1 activities that we did. We went over this pretty thoroughly with 2-3 different labs. And then finally, the last part for the group section is the conclusion. And so for the conclusion, should the reaction be used by colony pharmaceuticals to produce the aqueous nutrient? That's the question that you want to answer. So give a yes or no. Respond yes, no. Did you save your patient? Did you not save your patient? If there is a clear-cut yes or no, use % yield to logically support your data. So maybe you got 100% yield. That would be a great IV solution to give to that patient. Maybe you got a 5% yield. That would be a terrible, terrible solution to give to your patient. If maybe, or if it's inconclusive, you need to provide ideas for future tests. What can be done to do something better? In addition to meeting those proficient criteria, here are some examples of how to go above and beyond, but not limited to. You need to provide meaningful evidence and reasoning as to why or why not the reaction should be used to provide the nutrient. So is there other data surrounding the reaction you're doing, or is the nutrient you're producing that might influence your ultimate decision as to whether to use this reaction? So meaningful evidence, so use the internet, right? This is an open note, open internet, open peer final. Give reasonable ideas to make the process greener. For instance, how could one repurpose the precipitate instead of throwing it away? Because that's what we're going to do at the end of this lab. We're just going to throw it away. What could we do to make it greener? What can we use that precipitate, that solid for? If another group made the same nutrient as yours, how does their data compare to yours? You can ignore that one. Every group has their own reaction, so you don't have to answer that question. You can't answer that question. And then the last part is to provide a cost-benefit analysis of the chemicals we used, the time we used, is this a good IV, right? Greener processes, etc. For other parts of this lab, the presentation that you guys will be giving on your final day, central message in the overall presentation, so when you actually present it, you need to make sure that it's clear and consistent with the supporting material, that it's understandable but not repeated, right? And then if you want that extra points, those full credit for your presentation, the central message has to be compelling, right? Precisely stated, appropriately repeated, memorable, and strongly supported. The other thing is technology and time requirements for your presentation, right? You need to be mostly prepared with technology and or the presentation, whether you did PowerPoint, Prezi, Google Slides, poster, video, whatever you do. And then if you want full credit for that, you need to be prepared with the technology and the presentation, and it needs to be within about 10 minutes. So I'll give you guys about 10 minutes. I'll set a timer, but no less than 5 minutes. So between 5 to 10 minutes. I know this says 7, but I'm going to go ahead and change that to 10 minutes. So I will time you and I will cut you off at 10 minutes, but no less than 5 minutes either. So make sure you practice your presentations as a group so you know how long it takes you to talk. You'd be surprised how long and how short 10 minutes can be. And then finally, the individual student grades. This is going to be the last part of it, 20 points out of 80 points. The criteria for this is on-the-fly content question during the presentation. So if you want proficient minimal criteria, the student understands the concept but can only partially explain it verbally. Oops. I'm going to highlight that. Student uses correct vocabulary more than half the time, demonstrates an understanding of question, may require some prompting to fully answer the question. Right, so if you can do that, that will give you proficient minimal criteria. If you want full credit for this part of the presentation, when you are asked a question after your presentation, you need to be able to demonstrate a strong understanding of the question without any prompting. You need to be able to explain the concept thoroughly and accurately, and then show the correct use of all relevant vocabulary. So if you can kind of explain it, you're going to get proficient. If you can thoroughly explain it, you'll get advanced. And that's going to be for each person in your group, so every single person needs to talk. The questions that you can be asked after your presentation, so on-the-fly questions, every student, every table, every group will have this paper on their desk during the final. After the presentation occurs for you, every person in the room can ask you one of these questions, and it can be any of them, it can be some of them, it can be all of them. I will also ask a few questions as well. So you need to be prepared with how you can answer all of these questions. Right, so we have things like, was there a limiting reactant? Why or why not? How were the mole ratios used in the planning of this reaction? How do you determine the theoretical yield of whatever the chemical compound was? How do you determine the actual yield of whatever the compound was? How does being a hydrate affect the molar mass of the compound? And finally, for the stoichiometry topic, when calculating the percent yield, we assume that the product was 100% pure. Was it? Were there any sources of contaminants that might be present? So for this right here, topic stoichiometry, make sure you know and review, go back through your Unit 10 and Unit 11 notes. For the topic on properties of compounds, you need to be able to answer things like, what kinds of bonds hold together? Is it ionic? Is it covalent? Is it aqueous? Is it solid? Is it liquid? Is it gas? Stuff like that. Is it organic? Right? Question 8, what does it mean for a solid to be a hydrate? Draw a picture if you need to. Use the whiteboard. Number 9, why is a hydrate not considered a liquid? Number 10, where did the water in the hydrate go after you dissolved the solid? So use your nanoscopic representation to help you out with that. Number 11, what is a piece of evidence that bonds were rearranged when you mix the reactants together? And then number 12, was one of the reactants in the solid, so maybe calcium, was it sodium, what was one of the reactants in the solid? And where was it found at the end of the reaction? Was it in the aqueous solution, the nutrient that you gave in the IV to the car crashed patient, or was it in the solid precipitate that you filtered out? Choices made in the lab, there's 5 possible questions to be asked for that. In your situation, your percent yield was over 100%. What are some reasons for obtaining a percent yield under 100%? And then in your situation, your percent yield was under 100%. What are some reasons for obtaining a percent yield over 100%? Why is filtering a better choice to separate the precipitate over decanting? If you don't know what decanting is, go back to Unit 0, Unit 1, we talked about it. Otherwise, Google it if you've lost your notes. Number 4, why did you choose your method of filtration over other methods, right? So gravity filtration, that's what we used. There's also vacuum filtration, which we could have used, but we didn't. So why? What are some pros and cons of gravity filtration versus vacuum filtration? Google that. You have an open note, open internet final. And then number 5, determining the mass of aqueous nutrient produced. What are pros and cons of evaporating away the water to obtain the mass of the compound that was aqueous versus subtracting away the mass of water used in the reaction, right? So you could have used the Bunsen burner and the evaporating dishes, or we could have used the filter paper and the dryer oven. And so make sure you know why we did it, what are the pros and cons of that. If you have any questions, do not be afraid to ask. Make sure you read the rubric, reference the rubric, work on your PowerPoints and your presentations, and answering on-the-fly questions. You can be prepared, but you don't know which questions you are going to be asked. It will be completely random. So make sure you're prepared for all of it and that everyone in your group has the ability to answer any of those.